Hey folks, welcome to this episode on excess reagents and its calculation. So going back to this thing, we've seen this before when we were talking about limiting reagents. When we were looking at this, we saw that we needed 3 moles of hydrogen for every mole of nitrogen. And so here we kind of block them off in this. And right away we can see that we have these 2 moles of nitrogen that are not going to be used because we don't have any hydrogens left. And so enough, we have each of these 3 moles reacting with 1 mole of nitrogen to produce 2 moles of ammonia. Now in this case, again, the nitrogen is not used. Which one is our limiting reagent? Well, if we had more hydrogen molecules around here, we'd actually be able to convert these nitrogens into ammonia. But because we don't have enough hydrogen, our hydrogen is our limiting reagent, which means that these things are left over, and those things are called our excess reagent. So the excess reagent is just the reactant or the reagent that doesn't get completely used up in the reaction. There will be some left over. In labs that we do in high school, we usually do it so that we can make sure that the reaction goes all the way and that all of our reactants or one of our reactants is completely used up. In commercial chemistry, that's not so much the case. But sometimes there will be some left over, so we're going to try to figure out how we can calculate that. Now, the important thing to remember, this is really important, is that the value of the limiting reagent, the mole value of the limiting reagent, controls the entire reaction. It controls how much product is made, and we saw that as theoretical yield. And we also know that because it controls the reaction, it controls how much of the other reactant is consumed. And this is what our focus is going to be on today. So we talked about theoretical yield before. We want to see how much of the other reactant, the excess reactant or the excess reagent, is consumed. How much is left over, how much is used. So to calculate this, what we need to first do is figure out that limiting reagent, because like the previous slide showed, the limiting reagent, the value of that limiting reagent controls the entire reaction. So we first have to figure out what that value is, because that will tell us how much of the other reactant, the excess reagent, is used. So once we figure out how much is used through our mole ratio calculation, and if it's the question's asking how much is left over, we just subtract what we used from what we had, and we figure out how much is left over. So this equation is kind of set up for us already. Here we have some sodium reacting with chlorine gas to produce sodium chloride salt. So in finding out our limiting reagent, we first need to create this balanced equation. That was number 1. And then we take our starting values and divide them by the molar mass. Now when we do this, what we get is 2.17485 mole of Na, and here I have 0.705219 mole of Cl2. Now again, to figure out my limiting reagent, I need to compare how much of this reactant will produce of a product and how much this reactant will produce of that same product. Here we only have one product, so we can only choose NaCl. So in this case, I'm going to be comparing my mole of Na, that's what I want to get rid of, with my mole of NaCl, the product that I want to choose. And again, my ratios from this come from my balanced equation. I have 2 moles of Na for every 2 moles of NaCl. I put 2 and 2. And so it's going to be a very simple calculation. It's a 1-to-1 ratio, so we have 2.174859 mole of NaCl. Now we do the same thing for the bottom one. Again, we want to get rid of mole of Cl2, and we want to be left with NaCl because we want to compare the same product. So again, we go back to our ratio from our balanced equation, and we have 1 mole of Cl2 for every 2 moles of NaCl. So that goes here and 2. So we multiply that value by 2, and I get 1.410438 mole of NaCl. So now we've figured out how much product each of these reactants make, and we need to compare them. Now it's pretty easy to see. The one that produced the least amount of NaCl is this one over here, and the reactant responsible for that is our Cl2. So I'm just going to get rid of this here. I don't really need that anymore. So my limiting reagent is going to be Cl2, and the value for that limiting reagent is this one over here, 0.705219 mole of Cl2. Now, if that is my limiting reagent, which is my excess reagent? Well, it's the only other reactant that I have, so my excess reagent or my excess reactant is going to be Na. So it's the one that I have more than I need. So the question is asking us how much excess reagent is left over after the reaction. Now, think about when you go into a candy store and you want to buy some candy. You have $10 in your hand and you spend $8. How did you figure out how much you have left? Well, you probably know it's $2 left. But what you did is you took how much you originally had, $10, you subtracted what you spent, $8, and what was left over was the $2. Okay? So that's exactly what we're going to be doing. To figure out what is left over, we need to figure out what we have of our excess reagent minus what we use. Now, figuring out what we have is actually pretty simple. So we have of our Na, I'm just going to put here in subscripts, we know what we have of our Na because we already converted it. We had 50 grams, we just converted it by its molar mass, and we have this many moles of Na. So that's a very simple number to get, 2.174859 mole. Okay, that's how much we actually started with in terms of sodium. Now, what we used, that's what we have to calculate. Remember that the reaction is controlled by the value of the limiting reagent. Not only the amount of product that is made, but also the amount of the other reactant that is used. So to figure out how much sodium we use, we have to start off with our value of our limiting reagent, which is 0.705219 mole of Cl2. Now again, when I'm relating one species to another, in this case Cl2 and Na, I have to use my mole ratio. So I want to get rid of my mole of Cl2, be left with my mole of Na. And where do I find that information? Again, my balanced equation. So I have 2 mole of Na for every 1 mole of Cl2, and I get 1.410438 mole of Na used. Okay? Now folks, don't get confused about this value and this value. They are completely different. This is mole of NaCl, this is mole of Na. So this is how much Na I started off with. This is how much I used based on my limiting reagent. So what I have left over is very simple. I take 2.174859 mole of Na minus 1.410438 mole of Na. And my difference here is 0.764421 mole of Na. Now, usually when it's asking us how much is left over, we're talking about in mass. So all we have to do is convert that mole value into mass of Na. So I'm just going to rewrite it here, 7644421 mole of Na, and I multiply by its molar mass, which is 22.99 grams per mole. And my value with 3 significant figures is 17.6 grams of Na left over. So, pretty simple, as long as you recognize that the limiting reagent is the thing that controls everything. It controls how much product is made, and more specifically in this case, what's more important is that it controls how much of the other reactant, the reactant in excess, is used. So to calculate what is left over, I need to figure out how much of the excess reactant I have, minus how much I used. How much I have, I've already converted it, it's right over here. And how much I used my value of my limiting reagent, and our mole ratio between the limiting reagent and the reagent in excess to figure out how much mole of Na I used. I subtracted what I used from what I had, and I converted that into grams using its molar mass. So this is just a summary of what we did. We could have gone the other step and figured out how much that NaCl weighed, but we needed to do this step to figure out which one is our limiting reagent. And we figured out that our Cl2 was our limiting reagent, and so to figure out how much we had left over of sodium, we figured out how much we had. That was just our conversion initially. And then our mole ratio to figure out what we needed or what we used, and subtracted the two to get our final value here. And again, we converted that into grams to keep it in consistent line. So let's do another example here just to really hammer home the point. Here we have 1.22 grams of hydrogen reacting with 1.05 grams of nitrogen to form ammonia. Let's find the amount of excess reagent left over the reaction. So again, to figure out how much excess reagent I used, aka to find out how much I have left over, I first need to figure out what the limiting reagent is. To figure out my limiting reagent, I need to figure out the balanced formula. So in this case, I have H2 gas reacting with N2 gas to produce NH3 gas. So to balance this, I'm going to put a 2 here, a 3 here, and just for ratio's sake, I'm going to put a 1 there. So I have a 3 to 1 to 2 ratio. So let's figure out what my limiting reagent is. Let's start off by putting our values of our reactants here. So I have H2 and I have N2. My value for H2 is 1.22 grams, and here I have 1.05 grams. To convert from grams to moles, I have to divide by the molar mass. That's our first step. Get it to moles. So I have 2.00 grams per mole because it's H2. And for nitrogen, I divide by 28.02 grams per mole. So once I do this, I get 0.61 mole of H2. And here I have 0.0374773 mole of N2. Okay, now once again, to figure out which my limiting reagent is, I have to multiply by a mole ratio. I have to pick a product. In this case, I only have one product again, so I'm forced to pick that one. So I'm going to compare the moles of H2 to NH3 and also the moles of N2 to NH3. So here's my mole ratio for the first one. I put moles of H2 on the bottom and mole of NH3 on the top, and I get these values from our balanced equation. So that's going to be 3 moles of H2 to 2 moles of NH3. Moles of H2 cancel out, and I get 0.406667 mole of NH3. Okay, now I do the same thing for the N2. So I put my mole of N2 on the bottom, my mole of NH3 on the top. Again, I get it from my balanced equation, so I'm going to put 1 over here and 2 over here, so I multiply it by 2 divided by 1. These units cancel out, and I get 0.074946 mole of NH3. Okay, so now I have to compare which one of my reactants produced the least amount of product. Now that's pretty simple to see. This one is clearly not it. So my limiting reagent is my N2, and the value for that limiting reagent is 0.037473 mole of N2. Okay, remember I need to highlight that because this is controlling how much of the other reactant is going to be used. So it's asking me my excess reagent. Well, first I have to identify what it is, and it's going to be H2. So to figure out how much I have left over, I need to take how much I have minus how much I used of the H2. So in this case, I have, let's put it over here, I have 0.61 mole of H2. Now once again, where did I get that unit? It's right over here. I start off with 1.22 grams and I just converted it into moles. So I have this many moles from the beginning. To figure out how much I used, I need to start off with my limiting reagent because again it controls how much product is going to be used. So I have 0.037473 mole of N2. I need to multiply by a mole ratio. Mole of N2 will go on the bottom obviously. And I need to see how much of the excess reagent is going to be used up. So that mole of H2 will go on the top. So again, I go back to my balanced equation and I find that I have 3 mole of H2 for every 1 mole of N2. Those cancel out. I multiply by 3 and I get 0.112419 mole of H2 used. So I know how much I have and I know how much I used. I subtract one from the other. So in this case, I take 0.61 mole minus 0.112419 mole, and I get 0.497581 mole of H2 left over. Now again, if you want to leave it as mole, and that's what the question is asking you for, go ahead. But usually what we want to do is we convert it back into mass. So we have 0.497581 mole of H2 multiplied by its molar mass, which is 2.00 grams per mole, and I get 1.00 grams of H2 left over. And that's it. So take a few moments, try to figure this one out yourself. It says we have 15 grams of ammonia burning in 20 grams of oxygen to produce water vapor and nitrogen monoxide gas. So again, here we have two products being made. Choose either one, but just make sure you use that same one for both calculations of our limiting reagent. Once you find that, figure out how much excess reagent remains after the reaction. So again, the one that is the limiting reagent is not the excess reagent. So figure out what your limiting reagent is. The other one will be our excess reagent, and figure out how much is left over after the reaction. So pause the video, come back when you're ready, and we'll have the answers for you. Go ahead, pause the video now. So welcome back. Here's our balanced equation. We found out that our limiting reagent was our O2, and the value for that limiting reagent was 6.25 moles of O2. That's what we got over there. Because it produced the least amount of our reactant, of our products. In this case, I chose the NO gas. Here was 8.82, here was 5, so obviously this was the least amount of gas. To figure out how much of the excess reagent I have left over, I first need to identify it. Because O2 is my limiting reagent, my NH3 is going to be my excess reagent. So how much of the excess reagent do I have? It's this value right over here, I just converted it. And to find out how much was used, I start off with my value of my limiting reagent multiplied by the mole ratio of the two reactants, and I get how much ammonia I have used. So what I have left over, I take what I've used, subtract it from what I actually have, and this is how many moles I have left over. Converting it back into grams by using molar mass, I have 6.49 grams of NH3 left over after the reaction. That's it, guys. Thanks so much for watching. See you soon.